Okay, let's do the first example. First question. Here we go. Now, looks like a lot of gibberish here, but you just take it slow. Four factorial, we can see from the 4 is a 4, 3, 2, 1. Yes. 5 factorial is a 5 times a 4 times a 3 times a 2 times a 1. Now, over here, this looks really complicated. We can just cancel, Charlie. Exactly. 28. What could I cancel from the top and the bottom? 27. Well done. Because there's a hidden 27 in here. We take the 28 out. And what's left in the factorial? Not quite. 28. There. These two combine to make 28 factorial. Can we see that? Yeah. I just pulled it out. Oh my god. Okay. Yep. Remember that? 27 factorial we haven't touched. We pulled out a 27 factorial. 28 is now released as a person, gets to be free. As Shaka said, cancel, or whoever that was. 4, 3, 2, 1 is? 24. So 120. And then 28. Put them all together. What do you get? I did this earlier. That's 172.
Why did you do that before you even explained anything?
Okay. Are we good? Are we at peace with factorials?
Yeah.
Yes? Because it gets harder. Okay. All right. I'm going to connect today. We're going to connect our binomial theorem, Pascal's triangle, with factorials. You're going to see the connection. It's going to take a while to explain, but I want you to understand where it's coming from. Someone help me out. Pascal's triangle. I want to go down 4 rows. What's on the next row is that?
1, 2, 1.
1 and?
1.
1.
1.
1.
2.
2. Yeah.
3.
1. Let's do one more.
1.
Thank you. What row is the top row?
0.
Now, it is 0. Yes, Jesse, you are correct. 0. 2. Can anyone tell me when we're reading from left to right, what position is the 1?
0.
It's 0. Well done. Very good. This is 1. This is 2. This is 3, and so on. Okay, good. People are retaining information. Good sign. Now we're going to do something a little bit weird. I'm going to rewrite Pascal's triangle with factorials. 1. I know this is going to sound weird, but 0 factorial is 1. Okay, it's just like saying when you thinking of sums. When you start with sums, what number do you know? What's the center of sums? What's the number? What's the when we talk about numbers in general, adding and subtracting? What's the center? What's the starting point?
0.
It's 0. But Jesse, when we're doing multiplying, this is all about multiplying. What's the center number of multiples?
0.
It's not 0. It's 1. Because you have to start with something. If I multiply 0, I get
Zero.
0. We've got to start with something, and that something is a 1. That's why a 1 is a 0 factorial. Okay, so we're going to go here. This is the pattern that we do. If we are in row 1, our top numbers are 1 factorials.
Is 1 factorial 1?
Yes, it is.
Okay.
So 0 is a 1 and 1 is a 1. And notice they're all 1s. Okay? So look at the row. I'm going to put the row up here. Row 0, 1, 2, 3, and 4. If I go, our factorials also need a denominator. Okay, and this is how we do it. We go 0 factorial times 1 factorial. I want to see if someone can pick up the pattern. 1 factorial times 0 factorial. Okay, that's going to look weird, but it's going to explain itself in the second row. Have a look. If I'm in row 2, the numerator is now 2 factorials for each one. Denominator, have a look at the pattern. So I want to explain what's going on.
In the row, the denominator is row.
I'm going to go 0. I'm going to do this. I'm going to do this. I'm going to do this. And I'm going to do this. What's happening?
Right.
What's happening?
Denominator makes it 2, 1, and 1, 2, 1.
Yeah. What? Yeah. More detail.
2 factorial is 2.
Yeah.
And then 0 factorial is you doing 1 times 2. 2 over 2 is 1. And then you do the next one. Okay.
Good. Correct, Hudson. I need to make you are right.
That's why.
But how do we write it out? I'm going to do the 3, okay? This is important. If I'm in 3, what's on top?
3.
Okay. So we start off here. I'll just make sure these are out of the way. There's one there. There's one here. And there's one here. Underneath.
0 factorial times 3. Factorial.
Yes.
Factorial, yeah.
What's this one here?
It's 1 factorial.
Yep.
1 factorial.
No.
2.
Okay. What's this one here?
How is it times 2?
2 factorial times?
1.
Well done. And?
3. What's the need of factorial?
What is going on here? Okay, so let's focus on row 3. This is row 3 now. Let's pick on this guy in green. Okay, does this equal to 3?
Yeah.
It does. Do you want me to write it out?
Yes.
Or you're good?
How does
Okay.
1 factorial times 2 factorial equal 1?
Okay. Let's do
Oh,
it.
actually, never mind. Yeah, I get it. Yeah, I get it.
I hope it can. I'm going to do it black because
I can't get it set off.
people at home. Green's the worst color to use. Sorry, guys.
Which one 2 is?
All my fans.
It's okay.
3 times 2 times 1. 1 times 2 times 1. Okay. Cancel, cancel. 3. If we did the next row, which I'm not going to do, when we do the 6, it works out. You just need to know the pattern. Okay. Now, we're getting somewhere. I'm going to get rid of this. And we're going to now do this. All right. This is now we're going to go to binomial theorem. I want you to see what's going on here. Okay, this is 0 factorial. This one. I've got that there. Pay attention to the pattern. Two, two. Pay attention to the pattern. What should be on the next row?
3,
3,
0,
3,
2, 3, 1,
3,
3, 2. 3, 3.
Good. All right. Excellent. We are moving really quickly. What's going on here? Just a pattern. Okay. This here is related to this equation. If nothing made sense to you today, remember this one here. I'm not going to explain why this works, but I'm going to test it out. We have this, and it's called, let's just call this a locator. I call it a locator. When things are written just like coordinates, x's and y's, we kind of have x's and y's. When things are written like this, we can start finding. We know that this is a 3. We know that this is a 3. And we know that this is a 1. So I can, using this locator, I can locate, instead of writing this whole thing out, I can now directly go 3, 2. If I go 3, 2, I know that it's a 3. But what does Pascal triangle help us with? What is it? What's the point of Pascal's? What does it help us do? Find. It starts with a C. Not complete waste of time. O. Not quite. COE. Coefficients. Thank you, girls. Oops. We can now use two numbers to locate coefficients. Let's do this example here. Let's get into the examples. If you need to go to sleep tonight, you know what to do. Just get onto YouTube and just play my videos. Okay. All right, let's use the equation here. I have 5, 3. If I use this equation here, whatever n is n in here. Whatever r is r in here. Okay? Okay, so Charlie's going to work through it with me. What's on top, Charlie? It's a 5 factorial.
120.
On the bottom,
20.
is a 3 factorial. And inside, nice and slow, 5 minus 3. Okay. And it looks like, if I rewrite it as that, yeah. Well, I won't get into combinations yet. Too many new things happening. I've just applied the equation. Now let's try and work it out. 5 factorial. What's 5 factorial?
120.
120. What's 3 factorial?
6.
6. What's 5 take away 3 factorial?
114.
Yep, we're right. 2. Okay, so let's just do it like that. Okay, and we keep going. What's 2 factorial? 2. What's our answer? with 10.
How does that make sense?
Now,
5 factorial is 120.
let's look at it
and
carefully.
3 factorial is 6.
5 times 4 times 6 times 2
That's a good one.
3 factorial 3 times 2. It gets like a lot bigger. And then you times. Then if you have 6 factorial, it's like 7 times.
Yeah.
So it gets like a lot bigger. And then you times that by 8.
No, I'm just saying like 5 factorial minus 3 factorial and 3 factorial. But if you just like wrote it out, 5 factorial would be 120 minus 6. 140.
That's what I did, bro.
Okay, look carefully.
I'm baffled.
I'll help you out.
It's not 5.
Oh.
It's 5 minus 3.
It's a 5 minus 3, yeah. So, just to end this example here, Zach, focus. Just get this bit. Shaka, can you see it? Thanks. Here, we use 5, 3. We use the equation. We know that our term has a 10 in front of it. Okay, for this one here. If I do it with the Pascal's triangle, we want row 5, position 3. Row 5, 0, 0, 1, 2, 3, 4, 5, position 5, row 5, position 3. So I go 3 across. 0, 1, 2, 3. Can you see how they're the same?
Yeah.
Yes, exactly.
This actually makes that formula.
That's what we did there.
Sorry. What I'm trying to say, look carefully, guys, really pay attention here. You can do it with the equation, or you can do it by doing all the triangles. Which one do you want to do?
Triangles.
Okay, it's up to you. But what if it becomes position row 1000? Are you going to do a row 1000? A triangle? You're not.
No.
What are you going to do?
The equation.
The equation. Thank you, Zach. Use the equations. Now, if I do this, now you're going to hate me.